this would be logically ambiguous in logic, but its counterpart in mathematics, well, we know the order of operations. Here we're going to have what? We're going to have parentheses to help us out. So everybody understand that. Now, in mathematics, the last operation we would perform here is a plus, right? So we would call that a summation. We would say that this is a summation. Does everybody understand that? This expression is a summation. We do the same kind of thing with logical expressions in terms of referring to what kind they are. So imagine you're doing operations. All we have are brackets, and you know that you work from inside the brackets outward, right? So we would solve this, whatever that means, and then we would solve for this result with that result, doing the operation conditional. So that's our last operation. Everybody understand that? So what we would say is we'd say this thing is a conditional, okay? And this last operation we call the main logical operator, and we refer to this statement type by its main logical operator, which by analogy is the last operation we were performing if we were doing mathematics. Does everybody understand that? So the main logical operator, this is a conditional. What's the main logical operator of this one? The dot, because we'd have to work in the brackets first, and we'd have to take this result and AND it with the A, so the dot is the last operation we would perform. So the main logical operator is the dot. The horseshoe is called conditional, and the dot is a conjunction. Remember, conjunction, junction, what's your function? Okay, so everybody got that. The main logical operator is the last operator that you would perform, or last operation you would perform. Okay, all right, so hold on to that in your mind, and now I'm going to switch gears and prepare for the homework here. Okay, so we've been translating, and we might translate and get something like this: if A, then B, A, therefore B. Okay, and these letters, they signify particular statements. So this is a representation of a particular argument. Does everybody understand? These are statement constants. But let's suppose that we took out the statement constant and put in a variable, okay? And we'll represent variables by shapes. So wherever I have an A, let me use a box. Wherever I have a B, let me use a circle. So this would be a box, and this would be a circle, okay? So I replace statement constants with variables, okay? And so what we call this thing, it doesn't represent any particular argument, but it represents a kind of argument form. So we say that this is an argument form, okay? And we have a name for this particular argument form. It's called modus ponens, okay? And you will learn the names of all these argument forms later. But right now, what we're concentrating on is whether or not another argument is a substitution instance of a particular argument form. Okay, so what does that mean? Okay, suppose we got this argument form, and then we've got this argument, A, if and only if B, then not Z, and I've got A, if and only if B, and the conclusion is not Z. And I ask you, is this argument a substitution instance of this argument form modus ponens? That's what I'm going to ask you, okay? And now I'm going to show you how to figure it out, okay? notice that this argument form, the first statement is a conditional. The main operator is a conditional. And over here, the main operator is a conditional. So far, so good. And so what we say is we want a box, then a circle. So everything before this conditional, I'm going to call a box. Okay? And it's a rectangle, but just call it a box. Okay? And then it says everything behind the conditional is a circle. So not Z is a circle. Okay? And now what I have to do is substitute consistently. So wherever I see A, if and only if B, I need to use a box. And wherever I see not Z, I need to use a circle. Does everybody understand that? So when I come down here, I see A, if and only if B. Well, gosh, that's a box, okay? And then I say, hey, not Z, I've defined that as a circle. Does everybody understand? So now let's look at this form. Box and circle, box, therefore circle. Box and circle, box, therefore circle. They have the same form, so this argument is a substitution instance of this argument form. Does everybody understand that? And there could be countless substitution instances of this form. Does everybody understand that? Okay. Now, one important thing to clarify for you is this. Suppose that I solve this argument. Okay. And I said, is that a substitution instance of this one? You might say, well, first thing I need is a conditional. And I don't have a conditional, right? But if you look at the next line, you'd say, oh, this one is a conditional, right? And so what I'm trying to tell you is, when you're determining whether a particular argument is an instance of a statement form, the order, or argument form, the order in which the premises come is irrelevant, okay? Since I'm looking for a conditional first, mentally, I'm gonna put this one first, and then I'm gonna move that one to second. And then I'm gonna have exactly this again, and we're gonna find out it is an instance of that statement form. Everybody understand that, okay? So the order of the premises of the actual argument, you can move them around mentally, or sometimes it's better to just rewrite them in the order that matches up to the argument form better before you start trying to figure out if it is an instance. Everybody got that? Okay. So what I want to do now is I want to do the first problem from the homework. So we were given an argument form, and then you're given 4 particular arguments, and you're asked, hey, are these arguments instances of this form? Okay? And so first let's get up the argument form up on the board. We have box, then circle, we have not circle, and the conclusion is not box, okay? And this argument form is known as modus tollens, okay? And now we have 4 different arguments, A, B, C, and D, and we have to decide whether or not these are instances of it. So let me write down the A one, and let's see. We have not X then Y, and we have then not P then or Q, and that's 1. And 2 is not P or Q, and then the conclusion is not X then Y. All right, so how am I going to do this? First thing I'm going to notice is, hey, the first kind of statement in the argument form is a conditional. And by the way, if I'm just looking at that, that's the statement form, right? And the whole thing is a form of an argument, okay. So I've got a conditional, and the main operator of one is a conditional. Does everybody understand that? That's the last operation we perform. Okay, so far so good. So everything in front of the horseshoe I need to call a box. So, and that includes that negation right there, box. Everything after I need to call a circle, so, and that includes that negation, okay. So far so good, it matches, box, then circle. Now I need, not circle, okay. Wherever I have not P or Q, that's a circle. And I have, look, it's right here, not P or Q. That part's a circle, that is outside of it. Does everybody understand that? Because I'm looking for not P or Q. There it is, that's a circle. And we have this left over, okay? Now, this thing right here, box is not X then Y. Oh, there's a not X then Y right there with the negation on the outside, okay? Now let's look and see what we have. One is supposed to be a box then circle. Yeah, we have that. Line 2 needs a not circle. Oh yeah, not circle. Everybody see that? And 3, not box. We have a not box. Okay, so A is a substitution instance of modus tollens. Okay, and why is all this important? Because look, these argument forms that we're identifying, so far we've got modus ponens and modus tollens, they are valid, and we haven't explained what valid means in any technical way yet, but valid arguments are good arguments, and if a particular argument is an instance of a valid argument form, that particular argument is valid as well. Does everybody understand that? So we need to be able to abstract these argument forms and say, oh yeah, that's an instance of one of those, therefore it's valid. Everybody understand that? Okay. So let's try B. Okay, B is, one is not F if and only if B, and 2 is Z, then F if and only if B, and then the conclusion is not Z. Okay. So now the first thing I'm going to do is I'm going to notice that, oh, I'm looking for a conditional, but this is not a conditional, but line 2 is a conditional. Does everybody understand that? So mentally, I'm just going to move this up and then that one down. So I really want to have Z, then F if and only if B, and this one would be not F if and only if B. So I can keep this in my head, or I can actually write it down, reverse them, and then we have not Z. So, because remember I said the order of the premises doesn't matter. Did I say that already? Okay. So, I want to make this, see if it fits in this form. So I have a conditional, yeah, so let's call everything in front of A and C box. Everything behind is circle. And so wherever I have F, if and only if B, that's a circle. So there's a circle, and the negation is on the outside. Wherever is Z, I say it's a box. And so I would have that. And now let's see. Box and circle, yep. Not circle, yep. Not box, yep. So B would also be a substitution instance of modus tollens. Everybody understand that? Okay? So let's work on C and see if it is a substitution instance thereof. Okay? So C says X then Y then not P or Q. And 2 says not P or Q, and then it says not X then Y. All right, so I looking for something in the form of a conditional, and the first one is in the form of a conditional, that's the main logical operator. So let's let everything in front of the horseshoe be a box, and everything behind be a circle, okay? So I've called not P or Q a circle, and there's a not P or Q right there. Put a circle around it, and that means there's a negation outside, okay? Now we're looking for a not box, and so we need a not one of those, and that would be what? Not X then Y, okay? What we have is not X then Y. Are those two statements the same? Let me ask it this way. What is the main logical operator of 3? What's the last operation you do? Well, first you negate the X, and then you would want to do the then. Does everybody understand that? So then is the main logical operator here. But here, it says we have to work from inside the parentheses out. Here we would do this calculation, and then we would what? Negate it. So this is a negation. That's a conditional. These are not the same. Does everybody understand that? This is not a not box. This is a not box. This is what we're looking for. That's what we got. So doesn't match up. This one, C, is not a substitution instance of those tones. Everybody got that? Okay, and let's do D. Okay, D says not P or Q, then not Z, and 2 says not Z, and 3 says not P or Q. Okay. I need a conditional. The first line's a conditional. That much is great. Let's call everything in front of the horseshoe box. Everything behind the horseshoe is circle. Wherever I see not Z now, that's a circle, so that's a circle. And wherever I see not P or Q, that's a box. And I see a not P or Q right there, so this is a box and it has a negation outside, okay? Is this a substitution instance of that? Modus tollens, what?
No.
What's your name? You say no, I agree with you, why not?
The second one is not negated.
That's right. This just says circle, what do we need? Everybody see that? So, I'm not trying to trick you, but you gotta be on the lookout for these differences. Does everybody understand that? We need a not circle. We said circle was not Z, so what we needed on line 2 would have been a not Z, then we would have gotten a not circle, and then we would have had a substitution instance. Does everybody understand that? Okay, so your job, and by the way, I think we're supposed to have a quiz on chapter 2 due Sunday night. We have not finished chapter 2, so it is not due. Does everybody understand that? And I'll announce that on the Moodle page. Your job is to work on homework 2.2, and we will go over that next time, and then we'll push on to the next topic. And that's all for today.